Oh, I'm so excited. We get to start talking about integration. This should be your best day ever. Okay, so this first section is called Basic Approaches, which is super vague, but it's going to cover a lot of different types of topics. So essentially, everything that you currently know about integration, we can algebraically manipulate and take care of this stuff out of section 8.1. But there's going to be a lot of different approaches that we take here. All right, so we're not going to learn any quote unquote new ways to integrate here, but just things to look for so that you can manipulate the problems. All right, so up to this point, this is everything you've gotten out of Calc 1 and Calc 2 up to here. All right, we have just basic number, right? Something with an exponent. You know the antiderivative of cosine, sine, the secant squared, cosecant squared, secant tangent, cosecant cotangent. E, we just learned, right? That's just chain E. We've talked about that. Natural log, we just learned. The pattern for inverse tangent, we just learned. The pattern here for inverse sine, we just learned. The pattern for inverse secant, we just learned. Now, I said these are things that we already knew. However, these little fellas right here is brand new information. All right? But you still need to know these. All right? You still need to know these. So make sure that you're looking through these problems and you get it figured out and squared away. All right. The very first example that we are going to do right now is going to be to figure out how tangent works. So our first example, we're going to work on tangent. I'm not going to go through all the rest of these because you can solve them similarly, how we're going to do tangent, and then you can figure that out from there. But a couple things I want to point out. Don't get all wigged out because it's something new you're trying to look at. We're going to talk about tangent and the different pieces that are associated with tangent, so hang on to that here for just a second. Same thing with cotangent is going to look exactly the same. But think about secant. What do you know is a derivative of secant? Is secant tangent, right? So the antiderivative of secant by itself that's in here is 1 over a natural log of secant plus tangent. It's not that big of a deal. Cosecant, same way, negative because it's a co, and then the natural log of cosecant plus cotangent. So then that, it's no big deal, right? So you look at the patterns and the relationships, and it all works together. Okay, let's do tangent. So that you can see kind of how this plays out, and then I think that'll make cotangent and tangent work better for you. Example 1, we want to integrate tangent AX dx. All right. This is what we're looking at. We're actually just going to do the A. I'm not going to put the A in there. I'm just going to do X. Tangent X dx. The A, you know, just put the 1 over A in front, just like we do with anything. It's that, what we've been talking about, where you can skip that step, right? Now you're in Calc 2. It's that basic chain situation if it's just a number in there. So, all right. Tangent. We need to know something about trig, right? We're in Calc 2. It's trig all day long. So whenever I have tangent here, I'm going to take tangent and I'm going to change that to be in terms of sine and cosine. All right. Now, whenever I change this to be in terms of sine and cosine, we can do a sweet little u sub. Right? So u here is going to be cosine x. That means du is going to be a negative sine x dx. So I'm going to take that negative and put it in front. I take my sine x, sub it out with my sine x to make that my du. Put that negative in front. So I have negative 1 over u du. So I'm going to squeeze this in a little bit. Now, do you see where this natural log is coming from? Because we're using reciprocal identities there. All right. Yeah. So natural log, I'm using the fact that I have this in the bottom whenever I said reciprocal, crap and Atlas. Whenever we have a ratio identities, sine over cosine, I'm coming up with something that's a ratio. Okay. So 1 over u, we now know this to be a negative natural log of u here plus c. Okay, now I plug that back in. Negative natural log of cosine. Now what happens? Think about our logarithmic properties. So if I have logarithmic properties, I can take this negative in front and put it up here. Let me use a different color. If I take that negative and put it up high like that, that tells me that that's a negative exponent. Not inverse. Not inverse. A negative exponent tell me it's 1 over cosine. So I'm going to write extra steps here. So this is the natural log of 1 over cosine. Well, what's the same thing as 1 over cosine? Yes. It's secant. And that is where that comes from. So I'm going to squeeze this in so you can see this here for just a second. You see all that? Oh, it's pretty small. I'm going to make it bigger. So here, this is a natural log of secant. And again, right, this a is just a number. We know we can put that in front, whatever. But the natural log of secant. The natural log of secant happens that way because of this negative in front, because of my co. And then 1 over cosine is secant. And here's the other thing. Who's buddies with tangent? Secant, right? The derivative of tangent is secant squared. The Pythagorean identity deals with tangents and secants. So if you go back to thinking, what are the patterns I can look at in order to make these easier to work with? Bam, tangent goes with secant. Just secant by itself. Cosecant is cosecant, cotangent. Secant is both. But cotangent, by this same rationale of these ratio identities, sine is in the bottom. Because it's not negative, the derivative of sine is just plain cosine, then there's no reciprocal identities to go with, so cotangent is just straight up sine. Do you see that? Because sine would be in the denominator. The reason why I look at reciprocals because this negative out front makes that the reciprocal. That's not going to be the case if this were cotangent because cosine's on the top and sine's on the bottom. All right, so do you see what I'm saying? We haven't done anything new here. This is everything that we already know. It's just a different way to manipulate this so that we can then work with the integral. That's what we're going to be doing quite a bit of in this section right here. Okay, good.